Hi, this video is to help you understand and to practice balancing of redox reactions. Now, there are two methods in which we are going to review right now for balancing them. One method is called the oxidation number method, and this is used primarily for non-ionic compounds and for substances not dissolved in water. Whereas the half reaction method is used primarily for the opposite, basically for ionic compounds, especially those that are in aqueous solution and dissolved in water. So the first step for the first part is always to assign oxidation numbers and going through and using the rules for that. So first of all, looking at this equation, there are no pure elements, so there's no rule number one. Rule number two for ionic compounds, not really ionic compounds. Rule number three, oxygen, if it's bonded to a non-metal, it always has a -2 charge. So that's going to be -2, that's -2, and each of those are going to be -2. And then hydrogen, same thing, but with +1. That's +1. This is +1, and this is +1. And then rule number, basically we can, there is a pure element. Sorry, that's 0 there for the bromine. And then we can go to rule number 6, because all the rest of these are compounds, and we can basically say that the oxidation numbers for compounds have to add up to 0, and therefore we can figure out what's left over. So here we have a -8 plus 2 is -6. So this sulfur has to be +6 in order to balance. All right, let's get a little closer here. All right, and then for over here, this bromine has to be -1 to cancel out with that hydrogen. Over here on this side, sulfur is going to be +4 because you have two -2s for -4, so that needs to be a +4. And then over here we have the bromine being 0. So what is oxidizing and what is reducing? Well, if you notice, the bromine is going from -1 to 0. So we connect those with a line, and that is our oxidation. And we see that the charge is going from -1 to 0, so it's adding 1. For the sulfur, we see that it's the other thing changing. It's going from 6 to 4, so that is of a -2. All right. So now we look at these and we realize, well, whatever the negative number is, the positive has to be the same and vice versa. So we want to either multiply one or both of those so they equal the same number and therefore can cancel out. Remember, if you're going to lose or gain 2 electrons, they have to come from somewhere. So something else has to lose 2 electrons. So the least common multiple between those two numbers is going to be -2. It's going to be 2. So I'm going to multiply this by 2 to give me +2, which means that these guys, I have to have 2 of them. All right, I got to have 2 of them right here. Now looking over here, I already have 2, but over on this side, I'm going to put a 2 coefficient there so that I now have 2 bromines on that side. And then the hydrogens, just to double check, we have 2 hydrogens here plus 2 there is 4. Well, those aren't balanced, are they? Because on this side, we only have 2 of them. So the last step is we now need to balance out all the other substances and make sure that we have an equal number on each side. So I'm going to put a 2 here, and that way we have 2 hydrogens plus 2 hydrogens gives me 4, and over here we have 4 hydrogens. And just double checking oxygens, we have 2, 4 oxygens. We have 4 oxygens here. So now it is balanced. we would say that it is H2SO4 plus 2 HBRs react to form SO2 plus Br2 plus 2 waters. And that is the oxidation number method. Now, the reaction half method, all right, is done differently. And with this one, our first step is we start off with a net ionic equation, which basically means that we have a reaction that has gotten rid of all of the spectator ions, those that are not changing, they're just kind of sitting around watching. So we then go and looking at this, we want to write out the oxidation reaction and the reduction reaction. We want to separate them out. So we have to have the oxidation numbers for everything. Well, luckily, everything that is an ion already has its oxidation number. All right. And now we want to do this one over here. So oxygen is going to be -2. -2 times -4 is -8. So what plus -8 gives you -1 is +7. So it looks like, all right, iron is going from +2 to +3. So that is our oxidation half reaction. And then the manganese, along with the oxygen that's attached. Manganese is going from 7 down to 2. All right. So now we want to go through and balance each one. All right. First of all, we balance the charges. We balance the non-oxygens and hydrogens. One iron, we're good. Manganese, we're good. Next, we balance oxygens by adding waters to the other side. All right, that's how you balance oxygen. So we have 4 oxygens here. So we need to add 4 waters to this side. So we have 4 oxygens on each side. Then we balance out the hydrogens with H pluses. So we have 4 times 2 hydrogens on this side. So we need to have 8 H pluses on that side. 8 hydrogens, 8 hydrogens. And now we use, finally, the electrons in order to balance out the total charges. So over here, we have 2 is equal to 3 plus 1 electron. So both of those, this side has +2, that has +2. On this side, we have +8 minus 1 is +7. Over here, we have +2. So we need to add 5 electrons. Erase this here, give me a little more room. All right, we have 5 electrons on that side. So we have -5, -6, plus 8 is +2. And over here, we have +2 as well. So the charges are now balanced here. Charges are now balanced up here. Now, the next step is to make the number of electrons equal in both half reactions. So in this half reaction, we have 1 electron. In this half reaction, we have 5. So we want them to be the same number. The least common multiple of 1 and 5 is 5. So we're going to take this and multiply the whole thing by 5. And I'm going to put that down here, and I'm going to say we have 5 Fe2 pluses. Usually you want to leave enough room underneath. I didn't, sorry. All right, reacts to form 5 Fe3 pluses plus 5 electrons. All right, now we have our 2 half reactions. Number of electrons match on both of them, and then we recombine them by canceling out any substance that appears exactly the same on both sides and recombining all the reactants on one side and all the products on the other. So our final answer is going to be 8 hydrogens plus the manganate plus 5 iron 2s will react to form 5 iron 3s plus manganese 2 plus the 4 waters. And that is the balanced chemical equation for a balanced redox reaction using the half reaction method. Thank you very much. If you have any questions, please feel free to ask during the tutorial.